Good morning friends, welcome back to my channel Coding Environment. In this video, I am going to solve a problem on queue data structure. In any programming interview, you can get a question to write a program for queue data structure using the stack data structure. So let's see how we can solve this problem. So before I go and show you this program on Eclipse, let me show you the logic, what we are going to do to create a queue data structure using a stack data structure. So let's see what we have to do. So there is basically two operations we have to perform in any queue structure, right? One is the enqueue and one is the dequeue. So enqueue is like process of putting the data into that queue structure, and the dequeue is the process to take the data out from that queue structure. And as you know, that queue works on a first in first out principle. So the element which has been inserted into the queue at first will get removed from the queue at first. So let's see how we can implement this. So we have basically two operations. One is enqueue and one is dequeue. So to create a enqueue operation using a stack data structure, we have to use two stacks. Here, as you can see that I have created two stacks here. And the process which we have to follow is, while stack 1 is not empty, push everything from stack 1 to stack 2. So everything which is inside this, we have to take from this stack 1 and put into the stack 2. So this is the first operation we have to do when we are going to insert any element. After that, we have to push that element into that stack 1 and then push everything from the stack 2 to stack 1 again. So this is the three operations we have to do to perform the enqueue operation so that we can get our enqueue for the queue data structure. So let's see how we can achieve this. Let me give a demonstration for this. Now suppose I have stack 1 here and stack 2 here. And as you can see, it can take 5 elements and this also can take 5 elements. So let me put 5 elements into the stack 1 and stack 2 using this process. So okay, let me first mark the indexes of this array. So let me mark it. So this is my index 0, which is stack 0, 1, 2, 3, and 4. Similarly, this is again stack 0, stack 1, stack 2, 3, and 4. So this is the indexes for me. Now, suppose if I want to put 4 into that stack 1, or if I want to do this enqueue operation, basically I want to do this enqueue operation, what I have to do? I have to follow this process, right? So while stack 1 is not empty, put everything from stack 1 to stack 2. So at this point of time, you can see that the stack 1 is empty, right? So this operation I don't have to perform. Then push x to stack 1. So here the x is nothing but the 4. So 4 I have to put into the stack 1. So it will go and sit at this location, right? So I'm going to put 4 here. After that, push everything back to stack 1. So what I have to do, push everything from the stack 2 to stack 1. As the stack 2 is empty, I don't have to do any operation. So let's see, now put 2 into this. If I'm going to do a enqueue operation for this 2, what I have to do? I have to put stack 1 element into the stack 2. So this is the first element and this I have to put it here, right? So 4 will go and sit here and this 4 will get erased. So let me remove it from this. So I'm going to remove this. So 4 moved from stack 1 to stack 2. After that, it is saying put this element into the stack 1. So now I have removed that 4. So where the 2 will go and sit? 2 will go and sit at the index 0, right? So let me put that index, or let me put that 2 value here. And then what it is saying, push everything back to the stack 1. So push everything from the stack 2 to stack 1. So if I'm going to push, this 4 will go and sit here, right? And 4 will go and sit here, and this 4 will get removed. So erase this one. So this is the state of the stack 1 and stack 2 after performing insertion for the element 4 and element 2. Now if I want to insert element 7, let's see how these things are getting operated. So at this point of time, I'm going to insert this 7. So what I have to do, what it is saying, while stack 1 is not empty, push everything from stack 1 to stack 2. Now in this case, suppose if I want to take any element from this stack, which element will come out? As it is a stack, the last element which we have inserted into this stack will come out first. So we have inserted 4 at the last. So 4 will come out and sit here. And again 2 will come out and sit here. So this is our 4. Okay, let me clear this and make it correct. So this is the 4 and this is the 2. And then we have to delete this, right? So because we have already moved these two elements from the stack 1 to stack 2, these will get deleted. So erase these things. So this is the position. Now push X to stack 1. So I have to push to a stack 1. So this 7 we are going to insert here. So 7 will go and sit at the index 0, right? And then push everything back from stack 2 to stack 1. So in this case 2 will go and sit here because 2 will be coming first, and 4 will go and sit here. So 4 will be coming here, and this will get deleted from here. So let's delete this. Okay. So after insertion of these 3 elements, as you can see, the stack 1 is filled with 4 to 7. Again, let's insert some 2 more elements for better illustration or better understanding. So now I want to insert 1. Again, we have to do all the operation one more time. So this time I want to insert this 1 element. So where the 1 will go? Before we put this 1 into any one of the stacks, we have to move all the element from the stack 1 to stack 2. So again, this is the first element will come out from this stack 4, then 2, and then 7, correct? And then we have to delete this also. So because we have moved those elements, we will delete this. And then we have to insert that element, right? So let's insert that element 1 at the index 1. And then put all the element from the stack 2 to stack 1 again. So this is the 7 will go first time here, then 2, and then 4. And this will things will get deleted. So let's delete this. So this is the state of the stack after inserting element 1. Now again, let's insert one more element, which is 9. So before inserting again, we have to put these elements here. So 4 will come here because this is at this is the element we have inserted at the last, right? So 4 will come out first. So 4, then 2, then 7, then 1. And these things will get deleted from here also. So let's delete this. So 4, 2, 7, and 1 got deleted. And then we have to insert 9 here because this is the last element we are going to insert in this. So once we inserted this element, this post X we did, then we have to again put back all the element from the stack 2 to stack 1. So let's move it here, 1, 7, 2, and 4. And now let's erase these things too. So this is all about your enqueue operation. So whenever we are doing this enqueue, we have to do the 3 operations. One is like put all the element from the stack 1 to stack 2 first, then insert the element into the stack 1, and then again put all the element from the stack 2 to stack 1 again. So this is the operation we did, and after inserting, we have this. This is the structure we have got. So you can see it. This is the array. So this is the particular thing we have inserted. Now suppose you want to do the dequeue. So in dequeue, we don't have to do all these things. The first thing only we have to see is like the stack 1 is full or not. And if it is not full, we have to pop the first element. So suppose this is the thing, right? Now if I want to dequeue or remove the element from the queue, what I have to do? I have to call stack1.pop. So if the element is present, that will get deleted. So suppose if I am doing stack1.pop, which element will get removed from here? It will be the fourth element, right? This is the element which will get removed at the first time. Now why? So you see, 4 is the element we have inserted at first, right? And the 4 is the element which is getting removed also at the first. So this is what about that queue structure, right? The element which has been inserted into the queue should get removed from the queue also at first. So as we have inserted 4 here, so the 4 is the element which is getting removed. After that we have inserted 2, and then the 2 will also get removed if we do the pop operation on that stack. So similarly 7 will get removed, and after that 1, and after that 9. So in this we don't have to do a lot of circus. Only the thing which we have to check is the stack is empty or not. And if the stack is not empty, we can do that pop operation. So this is all the logic we are going to follow for this particular problem. Now let's run this program on Eclipse and see how these things are getting executed. So moving to the Eclipse now. So for the sake of the time, I have already written that program, and let me explain this. So this is the enqueue operation which we are talking about, right? So there are 3 operations we used to do for this. One is like move all the element from the stack 1 to stack 2. So you see, if the stack 1 is not empty, what we are doing is taking the element from the stack 1 and pushing into the stack 2. Also, if after doing this operation, what we are doing, putting that element into the stack 1, and once we put that element into the stack 1, again we are taking the element back from the stack 2 to stack 1. So this is the while loop which will do that operation of moving the elements from the stack 2 to stack 1. And again we are going to use that pop and push command only. So this is all about that enqueue operation which I explained just back into the PPT. And after that I have a dequeue operation also. For this we are just checking that the stack 1 is empty or not. And if the stack 1 is not empty, we are taking that first element which we can take using the stack1.peep, stack1.peek, and then we can return that element. So let's run this program into the debug mode and see how these things are getting inserted. So let me add some more element here. So right now only 3 is there. Let me add 5 elements so that we can be more clear. So this is the 4 and this is the 5. So now, as you can see, right, let me run this code into the debug mode. So you can see here, I'm trying to do this. So you can see here, I have 2 stack as I was explaining in the PPT. And I'm trying to do that enqueue operation. I'm trying to insert 1 into this. So my stack 1 is empty at this point of time. You can see that the stack 1 is empty. So it will not go into this for loop. And it will come out and put the element into the stack 1. So I'm going to put 1 into that stack 1. And again, as stack 2 is again empty, so this will also not get executed. So it will come out. Now suppose again I want to insert 2 element. So here it is going to check the stack 1 is empty or not. Now in the last we have seen that we have inserted the 1 element into the stack. So it will put this 1 element into the stack 2. What it will do, it will go and do this while loop. And after this operation, you see the stack 1 is empty and the stack 2 has the 1 element here. Now after that it will put that element into the stack 1, which is 2. So stack 1 is now having element 2, and the stack 1 is having the element 2, and the stack 2 is having the element 1. And after that, put all the element back from the stack 2 to stack 1. So stack 2 have 1 and stack 1 have 2. So once we do this while operation, you can see that the stack 1 has now 2 and 1, and then stack 2 is again empty. Again, if you want to insert 3, it will do the same thing. It will check that the stack 1 is empty or not. If it is not empty, it will put everything from the stack 1 to stack 2. So you can see it put 1 and 2 into the stack 2, and then it is putting the element into the stack 1. So here you can see it is putting the element into the stack 1, it put that element 3, and then it is again putting all the element from the stack 2 to stack 1. So this is all thing it is doing. Stack 1 has now 3, 2, 1, and this is the last element which we have inserted into this stack. So again, if I do this same operation for this 4 and 5, it will having the same thing. So let me come here and put one debug pointer here, and then run this in one shot. So let's complete this in fast. So see here, once we inserted all these 5 elements into this queue, my stack 1 have all the 5 elements, and you see this is the element we have inserted at the last. 5 we have inserted at the last, 4 after that. So now suppose if I'm doing a pop operation on this is the element which we have inserted at the last, right? And this is the element which we have inserted at the first. So which element will get removed? Can you guess? As we have implemented queue, and if we do this dequeue operation, it will give us 1. So let's see what it is printing. So once it will come into this, it will check that the stack 1 is empty or not, and then it will take the x element. This x value is 1, right? So this is the first element which we have inserted into the stack, and as per the queue, the first element which we have inserted into the queue, that element only will get removed from the queue 2. So it is coming out that first. Now it is returning, and see here, it is printing that 1. In the next it will print 2, and after that it will print 3 also. So you see here it print 2 and it printed 3 here. So this is all about implementing a queue using a stack data structure. So hope you liked this video. If you liked it, please subscribe to my channel and stay connected. Till then, have a great day and goodbye.